Now that we've talked a bit about how differential equations work, we want to talk about um, how we actually come up with some of these differential equations, how we take a situation and model it. So some key vocabulary that's going to come up is that we want to be looking at what they describe in a problem or what we expect from observing things in reality, and then identify the relationship between the rate, so the d something by d something, and relate it to other factors. So a bunch of keywords are going to come up. So you've got proportional. So A is proportional to B will mean something like this. And all that we're talking about with proportionality is that if A doubles, B will double. I'll talk about K here in a second. If A gets cut in half, B gets cut in half. K is what's known as the proportionality constant. And it just functions in a way to say that A doesn't necessarily equal B. So an example that shows this is that the area of a square is proportional to side squared. Right, if I square the edge of a square, I'll get the the proportional area. If I double the sides, I have to double the area because it's squared. But also the area of a circle is proportional to the radius squared. And you can see now why we need that constant, because yes, if I square the radius, I'll get 4 times the area, but the radius squared is not equal to the area, and that's just from looking at these equations. So area equals side squared, area equals pi r squared. So we can see the proportional just means there's a constant. So you can think about with the area, it's like there's a 1 there. Inversely proportional is similar. It's A equals K over B, and again, we just have this proportionality constant, and that's connecting with the idea that if A doubles, B gets cut in half, or maybe it's easier to see if B doubles, A gets cut in half. If B goes up by 4, A goes down by a factor of 4, etc., etc. Squared, cubed, etc. We've already seen an example up here with side squared. That just means you have to square whatever quantity you're looking at. Square root, cube root, etc. It'd be the same thing. We could say that the side of a square is proportional to the square root of the area. And then ratio, that would just be something like A is proportional to the ratio between B and C. And you'd set up a ratio like that. This will hopefully make more sense as you practice and as we look at an example here. So a bird gains weight at a rate approximately inversely proportional to its age t, right? A differential equation to describe this. So we're looking at the change in weight because we're saying the rate of the weight. So it's dw, and we're talking about the rate of change. It makes sense to be talking about time. It's not quite clear here. It will be clear in other problems that you would deal with. So dw dt, that's our rate. And we want to know what it, how it changes. And so it says it's inversely proportional to its age in terms of t. So I need k times 1 divided by t. So as the bird gets older, the rate at which it gains weight decreases. So this would be an example of a differential equation to model a situation. As a second example, the fraction of people P that hear a rumor increases at a rate proportional to the fraction of the population that haven't yet heard the rumor. Write a differential equation to describe this. So again, we're talking about probably a rate over time, so dP by dt. And that's going to be proportional, we need our proportionality constant, to the rate of the the fraction of the population that haven't heard the rumor. Well, if this is the fraction that have heard the rumor, haven't heard is equal to 1 minus p. And that's just because, you know, if a fraction of people have heard, however many minus 1 minus that much is how many haven't heard. So we have k 1 minus p. So here's a differential equation that describes how many people have heard. Basically, the more people that haven't heard, the faster people learn about it. And that kind of makes sense. Try a couple examples with this. Let me know if you have any questions, but otherwise we'll wrap up here.